Now we're going to talk about how functions are implemented. In other words, what happens in the machine when a function is called. The first thing you need to know is that each function has a block of memory reserved for it, and that's called its activation record. So that activation record contains the local variables for that function and other information that the function needs. The second thing you need to know is that the activation record is created dynamically. It's created when the function is called because it doesn't need to exist if the function is not executing. And the third thing you need to know is that the dynamic allocation of activation records is done on the stack. So as the function main calls the function draw, the activation record for draw gets pushed onto the stack. If draw calls another function, draw square, its activation record gets pushed on the stack, and so on. And when a function returns, its activation record is removed from the stack. It's popped from the stack because it's no longer needed. So the stack is the perfect data structure for this because of the last in, first out nature of a stack. We push things, and the first thing we pop is the last thing we push. Well, the thing that returns is the last function that was called, and so the call return sequence of functions perfectly matches the last in, first out, push pop sequence for a stack. So every system has something called a runtime stack that's used to hold the activation records of all the functions that are currently active in the program. And the one on top is the one that's currently executing. So let's look more carefully at what is inside the activation record. So this is specific to the LC3, but every system will have some similar kinds of structure. So we have three sections of the activation record. This whole thing is one activation record. So we have local variables, which we've talked about before, and we know that R5 points to the beginning of that local variable section. Then we have what's called bookkeeping information, and in the LC3 specifically we have space for the return value that the function is going to return. We save a copy of the R7, the return address, because if this function calls another function, the JSR instruction is going to clobber R7, so we need to save a copy of that so that we can get back to the caller. And finally we have what's called the dynamic link, which is the old copy of R5. When the caller was running, R5 was pointing to its local variables. When our function is running, we want R5 to point to our local variables. So we save the old R5 so that we can restore it when we're done. So that section we call the bookkeeping section of the activation record. And here is the parameters. So these are values that got passed in from the caller to our function, and we give names to those as we've seen in our function declaration. So this activation record corresponds to this function definition. When this function foo is called, it has three integers that are passed in as arguments. Those integers are bound to these names. So A is here, B is here, and C is here. C, B, A, C, B, A. Okay, and then X, Y, Z are the local variables, so there's space allocated for them as well. So when a function call occurs, there's two sides of that function call. There's the caller of the function, and then there's the code that executes in the function itself. So let's look at what happens on the caller side to begin with. So we're executing over here. Before anything happens, the caller's activation record is pushed onto the stack. I mean, it's already there because it's executing. So R5 points to its local variables, R6 points to the top of the stack. When the caller wants to call another function, the first thing it does is it pushes the arguments, the values that are getting passed into the function, onto the stack. So it does that from a right to left perspective. So it pushes the rightmost argument, the value that corresponds to the rightmost argument, and then the next, and then the next. So here we see, using our foo example from before, we have 3 parameters. Here, here, here. We push those 3 things on the stack. R6 moved up to here because we pushed things on the stack. R5 still points to our local variables. Once we've put those values on the stack, we then use JSR to transfer control over to the function that we want to call. Now we know from 109 that JSR then executes, will cause instructions to be executed in the called function, and eventually you'll hit the return instruction and that'll come back to us. When control returns back to us, the stack looks like it did when we started, but there's one additional piece of information that has been pushed on the stack, and that's the return value. This is the thing that was calculated by the function that the function is returning to us, and we find that at the top of the stack. So now we can read that value from the top of the stack and use it. We also need to pop off the values that were placed there again, and at the end, when we're done with the function call, we've used the value. There's nothing more on the stack other than the original activation record that we started with. So this and this are exactly the same. Now from the callee's point of view, the function that's being called, here's what happens. When we start executing, the caller has already pushed things onto the stack, right? Those things on the stack are the parameter part of our activation record. So the caller has already built part of our activation record, A, B, and C, right here. The first thing we do inside the function is we have to finish building the activation record. So we start with this, right? That's given to us, and then we push this other information onto the stack. So we leave space for a return value if there is one. We push R7 to remember it. We push R5 because we're going to change R5 to point to our locals. We push space for our local variables, and we see R6 has moved from here to here as a result of all this pushing. And we also set R5 to point to this location, which is our local variables. Now anything we do is relevant to R5. Relative to R5 is going to access things in our activation record. That's what's called, that code has to execute on any function definition. So every function definition, if I say generate code for this preamble code, I call it, has to happen because we have to finish building our activation record before we can start executing instructions in our function. At some point we're finished with our function, we're ready to return a value, and when we do that we store the return value into this space that we allocated for it, return value here, right? So here we restore the return value, we restore R5 and R7 to what they were. So as we pull these things off the stack, we take this and we put it into R5 so that R5 now points to the caller's local variables, which is where it was originally, and we clean up all this other stuff so that when we return control from us to the caller, this is what the stack looks like. Return value on top of the stack, the parameters are still on the stack. This is the way that the caller expects the stack to look like when we're done.